Hi guys, and welcome to the video. Today we're going to be looking at sorting algorithms, that is under the GCSE Computer Science course in accordance with the AQA exam board. In the top right hand corner you've got the usual course specification reference for this topic, and you've got both the content and additional information being covered. Just as a first point of call, if you haven't watched my representing algorithms or efficiency of algorithms videos, please do that now before you watch on, because it will just make a little bit more sense for you. We're now starting to talk about particular types of algorithms, and it would be better for you to have a more general understanding and appreciation of algorithms before you go into this. So just as a tip, watch those first and then please do come back. Otherwise, we're going to start off by talking about a particular type of sorting algorithm. Now, there's two different types we're going to look at today. Please make sure you also watch the searching algorithms video, which will talk to you about, again, a different type of algorithm there. But as a general definition for you, the definition of a sorting algorithm is a process to order the set of values contained within a list of data or an array of data. The user provides the list of data, and then the algorithm carries out the ordering of that for them. And there's two different types of sorting algorithm that we're going to look at today. The first one is a bubble sort, and the second one is the merge sort. Now, the bubble sort uses iteration or looping in order to compare adjacent values within a data structure. And what it does is, based on the ordering that's required, whether that be ascending or descending, it will then swap those values in order to achieve the sort that's being asked. The bubble sort is named so because of the number of passes that it has to make over a data set in order to fully sort a list. If it's only ever swapping adjacent values each time and moving sequentially across the list, after one full pass, it can't guarantee that the numbers are going to be in order. And if you sketch out a bubble sort and how the values are being swapped each time before you get to the final sorted list, the way that the values are actually pictured and drawn, as you sketch it out, actually look like bubbles sort of rising up through what could be a fish tank or something. So that's where the name comes from. It isn't that important. What's more important is that you appreciate the workings of it, and I'm hoping to show you that today with the use of this particular algorithm. Now, this piece of pseudocode I've put together, you're welcome to flip into a language of your choice if you wish. Again, as spoken about before, the top there is the list of items that's been provided by the user. The user is requesting that these be sorted in an ascending way, which you should always assume by default unless you're told otherwise. And what we then do is we then have a nested iterative structure. The first iteration that we have, definite iteration this time, states that for x in range, or the length of the list items, or for every time that there is a number inside of those list items, so we can spot very quickly how many times this is going to go on for. We then want to carry out a second sort of form of definite iteration within that. And we then have for y in range list of items -1. Now, the reason we have that -1 is because we don't want to check a single number against itself. You only ever want to check it against the other values inside of that list, which is why we can make this particular form of iteration repeat for one less amount of times. And then what we do is we say, if the list items y, i.e. our second item in our list, is greater than or equal to, in this case, the number that is going to be next along from that. What we then do is we then want to go ahead and swap these round. Now, the issue we have is if we simply reassign the value in our first item to our second item, we're actually just going to duplicate that value. We're not actually going to swap them round. And so that is why we have the presence of this temporary variable, which is merely used just to temporarily store a value whilst we reassign a value into another place, just so that we can swap them round. And so the first thing we do is we make the number that is next along, if you like, we assign that to the value of temp. And what that then allows us to do is to then assign our value that is currently out of position into the value that's further along, the space that's further along. And once we've done that, we can then take the value back out of temp and put that into our first position. So that will then sort effectively for you the first two values. And then this repeats all the way through the list and continues to go through the list until it's completed comparisons between each of the numbers, and it has swapped them around if necessary. So feel free to take that piece of pseudocode and use it as you see fit. The second type of sort we're going to talk about is the merge sort. Now, this uses a programming construct, if you like, that's referred to as being recursion. Now, recursion is a technique that essentially allows a function or a procedure to reference itself, to call itself again from within itself. The nature of recursion, just for your own awareness, is that it is heavily inefficient in terms of the amount of memory it can end up using when it carries out a procedure, but it does have its uses, and the merge sort is just one example of where that is. And the way this works is it essentially divides the list of data up into individual items initially, and then merges them back together in groups of 2, then 4, etc. And with each sort of reconstruction that it does, it completes the sort at that level. And then what you end up with right at the very end is a fully sorted set of data. So the pseudocode I'm providing you with here is very brief. If you were to go and actually write an algorithm for this, it would take you a while to do. But ultimately, what this is doing is it's looking at putting together the two main functions here. One is which is a merge sort, and the other is what I'm calling just a merge. And we take our list of items. We then scatter that essentially across 2 initial variables of h1 and h2, half 1, half 2. And then what we do is we then perform the merge sort, which is on the left hand side again, on both of those again. And what you begin to do is break this up step by step until you end up with individual values, and then you call merge on both of those sets of data. And what that then does is makes the comparison and then sorts them if needs be, switches them around before then rebuilding the list back together and re-merging them. So there's a piece of pseudocode for you to have a bit of a closer look at. Again, feel free to flip this into your preferred language if you wish. Otherwise, it's there for your own observing. Now, as I did with the searching algorithms, I'm just going to make some comparisons for you with the sort. The bubble sort is considered to be slower in comparison, as it has to complete several passes in order to fully sort a list of data. It's more memory efficient, as all the data is stored inside of a single list, and that list isn't being duplicated or split up at any point in time. We're just moving the values around within it with the addition of a temporary variable. In comparison, the merge sort is considered to be faster, and as a set of data gets larger, it doesn't really take it any longer. In a similar way to when we did our searching algorithms and we looked at the binary sort, it just doesn't really make that much difference if the list gets larger. It works recursively, and so, as I've said already, it's much more memory dependent. Because you are essentially duplicating the same list multiple times, but just in smaller versions in order to sort things out. So there's a summary of the two as well. I hope that's useful.